Hello friends, welcome to 360DigiTMG. I am thrilled to have you here today as we dive into an exciting and transformative topic in the world of AI, that is LLM, Large Language Model. So, what is it? What is large language model? So, a large language model is a type of artificial intelligence, that is AI, program that can recognize and generate text amongst other tasks. LLMs are trained on huge sets of data, hence the name large games. LLMs are built on machine learning, especially a type of neural network called a transformer model. They are capable of performing a wide variety of tasks, including natural language processing tasks like text generation. In text generation, it can generate like LLMs can be used to generate different creative text formats of text content like poems, code, scripts, manual pieces, emails, letters, etc. And in question answering, LLMs can answer your questions in an informative way, even if they are open-ended, challenging, or strange. Machine translation. LLMs can translate languages fluently and accurately. Like it can translate a language from Hindi to English, like that. Text summarization. LLMs can summarize large amounts of text and extract key informations. Okay, if there are like huge informations there, huge book there is there, we can summarize that book into small summary, small pages or small in few handy thing. How LLM works? So LLM works on massive data sets. LLMs requires vast amounts of data, vast amounts of text and code data to train and develop their capabilities. This data can come from books, articles, websites, codes, repositories, and so on and so forth. The diversity and quality of the data are crucial for the LLM's ability to understand and generate different types of text. The more data an LLM is exposed to, the better it will perform across various tasks. Deep learning architecture. So it has a deep learning architecture like LLM typically uses a typical or a type of neural network architecture called as transformer. This architecture is specifically designed to process and understand sequential data like text and all. Okay. Then transformers. Transformers are made up of multiple layers that work together to identify patterns and relationship between words and sentences. And each layer builds upon the knowledge of the previous layer so that it contains a memory also, allowing the LLM to learn increasingly complex representations of languages. Now, let's discuss about training process. So, training an LLM involves feeding a model large amount of data and correcting its mistakes as it learns. Okay. This process can take weeks or even months depending on the size and complexity of the models. During training, the LLM is represented with various text samples and corresponding tasks, such as predicting the next word, what will be the next word, or answering a question. There will be some question you have to answer, like that. If the LLM makes a mistake, its internal parameter is adjusted to improve its accuracy on the future tasks. So this is how the training process works. Interference process. Once trained, the LLM can be used to perform various tasks by providing it with prompts and context. Okay. For example, to generate a text, the user might provide a starting sentence or a topic as a prompt. Like there are different types of prompt techniques which we have learned earlier. So From this prompt technique, we can give an LLM a prompt so that it can generate output as we want. The LLM will then use its knowledge and understanding of language to generate text that is relevant and coherent. Similarly, to answer a question, the user would provide the LLM with the question itself and any relevant information. The LLM would then use its knowledge and understanding of the knowledge to find the most accurate answer for it. Okay. Then there is foundation models of LLMs. So LLMs, the marvels of modern AI, rely on a powerful base known as foundation models. These models are building blocks upon which LLMs are built, providing the initial knowledge and capabilities necessary for its diverse functionalities. Foundation models are large, pre-trained language models, are trained on massive amounts of data, as we have earlier also seen. They are not task specific, but rather are designed to learn general knowledge about language and the world. This allows them to be fine-tuned for a wide range of downstream tasks such as natural language processing, machine translation, content creation, text summarization, question answering, and so on and so forth. Examples of foundation models are BERT, bidirectional encoder representations for transformers, GPT-3, that is generative pre-training transformers 3, T5, that is text-to-text transformer, Lambda, that is language model for dialogue applications. So these are all the foundation models. So let's discuss about the first two, BERT and GPT-3. So GPT-3. What is GPT-3? As we all use GPT-3. GPT-3 stands for Generative Pre-trained Transformer 3. It's a large language model developed by OpenAI in 2020. LLMs are designed on massive amounts of text data, as we know, allowing them to generate text, translate languages, write different kinds of creative contents, and answering your questions in an informative ways. These are all the applications of LLM. Okay. Then GPT-3 is known for its impressive capabilities in generating creative text formats like poems, code, scripts, musical pieces, emails, letters, etc. Key features of GPT-3. These all features can be done by GPT-3, okay? From writing poems, code, scripts, musical pieces, like that. Now, the key features of GPT-3 is generative. Generative can create a new text based on the existing patterns and prompts. It can generate a new text on existing patterns and prompts. Okay. Then informative. It can answer questions in a comprehensive and informative way, even open-ended, challenging, or strange ones. Then adaptable. Can be fine-tuned for specific tasks by providing additional training data or human feedbacks. Accessible. Available through OpenAI's API for developers and researchers. So we require OpenAI's API key for further access if we want to get that specific. Then how does GPT-3 works? So GPT-3 is a language prediction model. It that can generate text, translate languages, write different kinds of creative contents, answer your questions in an informative way. It was trained on a massive data sets of text and code called as Common Crawl, Web Text 2, and Wikipedia. the massive data sets of text and codes are taken from all these websites. GPT-3 undergoes both supervised training and reinforcement phases during training. With over 175 billion parameters, it surpasses previous large language models like BERT and Turing NLG. The model's performance improves with addition of more data and parameters, enhancing its generation and capabilities. Okay. So when a user provides text input, the system analyzes the language and uses a text predictor based on its training to create the most likely output. The model can be fine-tuned, but even without much additional tuning or training required, the model generates high-quality output text that feels similar to what humans would produce. So as we can see here, these are the parameters of transformer-based language models. So here are the numbers of parameters wherein the data set is trained on, and these are the model names. So GPT-3 has 175 billion parameters and BERT has 345 million parameters. Okay. And other tuning NLG is having 17 billion. Then GPT Neo has 2.7 billion. GPT-2 has 2 billion parameters. So these are all the parameters on which the model has been trained. So maximum is of GPT-3 only. Okay. Right now there is again enhancement is going on. Then there is applications of GPT-3, chatbots and virtual assistants. GPT-3 can power chatbots that can hold language and engaging conversations. Content creation can generate creative text formats, like as we have seen poems. It can write a poem on certain topics also. If we give a condition to write a poem on this topic, so it can write a poem on a specific topic also. It can generate a code. It can write a script for a particular, if we want a script for a particular matching movie, it can write a similar matching movie scripts also, giving musical pieces. It can generate new AI music pieces. Okay, lots of things are going on. Then translation can translate languages with high accuracy. Then summarization can summarize large amounts of text into concise summaries. Then there is code generations, can generate basic code based on large language descriptions. Then there are certain limitations of GPT-3. Okay, so the first limitations of GPT-3 is pre-training. GPT-3 is not constantly learning. It has been pre-trained, meaning it doesn't have an ongoing long-term memory that it learns from each interaction. It learns, it has memory for certain period, but it doesn't have memory for a long-term memory. For a particular session, it has a history. It has a history that is long-term memory. There is a memory option there is, but for a long term, it doesn't. Limited input size, that is transformer architectures, including GPT-3, has a limited input size. A user cannot provide a lots of text as input for the outputs. We can limit certain applications, which can obviously can lead to which can also limit to certain applications. GPT-3 has a prompt limit of about this much token, that is 2048 tokens. It has a limit of this much. Okay, so this can also be a disadvantage, that is limitation. Slow interference time, that is GPT-3 also suffers from slow interference time, since it takes a long time for the model to generate results. Lack of explainability. GPT-3 is prone to same problems many neural network faces. Their lack of ability to explain and interpret why certain input results in specific outputs. Okay, so there is some disadvantages of this, but there are lots of advantages of also this, but there is always scope of improvements. Okay, so these are all the GPT-3 examples. This is how GPT-3 can work on, like create memes, quizzes, recipes. We can add some, we want a recipe of this dish. It can provide comic strips, blog posts, advertising copy, write music, jokes, social media posts, automate the conversational tasks, responding to any text that a person types into a computer with a new piece of text appropriate to that context. It can write like this also, automate the conversational task. Okay, then translate the text into programmatic commands, translate the programmatic commands into text, like explain me this program. So it can explain you like this in text format, perform sentiment analysis, extract the information from contracts, generate a hexadecimal color based on text description, write boilerplate codes, find bugs in existing codes, uh, mock-up websites, generate simplified summarizations of text, translate between programming languages, and perform malicious prompt engineering and phishing attacks. These are all the things GPT-3 can perform. Okay. Now, what is BERT? So BERT stands for bidirectional encoder representations from transformers, which is based on transformer itself, a deep learning model in which every output elements is connected to every input elements, and the weighting between them are dynamically calculated based on their connections. Then BERT, a Google creation from 2018, revolutionized the natural language understanding tasks like sentiment analysis and identifying words with multiple meanings. Unlike predecessors like word2vec, BERT excels at interpreting concepts and ambiguities effectively, approaching NLUs with a common sense like similar to that of humans. Google integrated BERT into their search algorithms in 2019, aiming for more natural user experience. Organizations are advised to focus on natural contents as BERT optimizes for authenticity, not manipulations, and it can be used for over 70 languages now. Benefits from BERT's NLU provies. Then there are some key features of BERT. Bidirectional understanding, that is, unlike other traditional models, BERT analyzes each model in its context, considering both past and future sentences. This gives it deeper grasp of meaning and intent. Then it can be used for like question answering champions. Then it can use for sentiment whisperers, concise summarizers, natural language maestros. So these are all the key features of BERT. Okay. So then how does BERT work? So BERT work on large amounts of training data. So BERT is specifically designed to work on larger word counts. The large informational data sets have contributed to BERT's deep knowledge of language and many other languages. Deep knowledge of English and many other languages. When we want to train BERT on larger data sets, it takes more time. Training BERT is possible because of transformer architecture. It has encoder-decoder architecture and speeding it up using a tensor processing units. So this is the first step, large amounts of training data. Then there is second step, that is masked language model. Masked language model is which enables the bidirectional learning from the text. If this we can identify from the image also. We can do it by hiding a word in a sentence and forcing BERT to bidirectionally use that word on both the sides. That is, we can try to understand the previous and next word of the hidden words for predicting it. We can easily predict the missing words by considering the word bidirectionally after and before the hidden text, as it provides the context clues. The bidirectional method used here will help you achieve the highest accuracy. See, as a random 15% of tokenized word are masked during training, and BERT's job is to predict the word. And BERT's job is to predict that word. See, in this example, this is the input and this is how the output is done. Okay. Then there is next sentence prediction. In next sentence prediction helps BERT learn about relationship between the sentences by predicting if a given sentence follows the previous one. Like in training, 50% of the correct predictions are fixed and 50% of random sentences to help BERT increases its accuracy. Then there is transformers. BERT's secret sauce is the transformer architecture, which trains faster and understands the context better, similar to how the human focus. Transformer sends attention signals to keywords, ignoring irrelevant ones. This efficient learning powered by encoder and decoders allows BERT to process massive data and shine in tasks like translation, question answering. Think of it as in focused learners, making sense of world like that. So fine-tuning the BERT model. So using these steps, we can fine-tune the BERT models, like get the data set. Okay, start exploring the data sets. We should start exploring the following, like getting ready for the BERT text classification task, like training and testing data and all. Okay, then data monitoring. Data set must be generated and optimized on a CPU. Processing. Then we should obtain a TensorFlow hubs pre-trained BERT frameworks by analyzing all these things, like analyzing a few training set tokenizing IDs, acquiring the tokenizers and BERT layers, creating the TensorFlow operations to encapsulate the Python functions for execution, and so on and so forth. So then there is designing the final input pipelines, then BERT classification models. We should develop, train, and monitor the BERT classification models and updating and saving that models. So these are all the fine-tuning steps. Then BERT's NLP applications. As we all know, these are all the applications of BERT NLP applications. Okay. Then limitations and challenges of BERTs. So there are computational resources and training time. It will require a huge training time. Okay. And then handling multigunal and multimodal data. Like if you want to extract from text to image and image to text, it will be a challenge for BERT model for that. Okay. And ethical considerations and biases. As with any AI model, BERT can be susceptible to biases in its training data. Yes, that is true. Then there is GPT versus BERT. GPT versus BERT is, as we can see here, there is GPT-3 and there is BERT. So we can see that this model has, GPT-3 has auto-regressive model and BERT model is discriminative model. Okay. Then the objective of GPT-3 is to generate human-like text. And the objective of BERT is to recognize the sentiments of that text. Okay. Then architecture. It is having a unidirectional architecture and it is having a bidirectional architecture. Okay. Wherein it processes the text in one direction using a decoder. And here it processes the text in both the directions, like in from the starting of the text and from ending, both the sides we take, and we take it as an using encoder, and it is trained on 175 billion parameters, which is very huge. And here BERT is trained on 340 million parameters. Okay. Then there is training data. Training data is, it is trained on huge modeling by using hundreds of billions of words. Okay. It is trained on language modeling, and it is trained on 340 million parameters. Then pre-training. Pre-training is done on unsupervised pre-training on large data. This is unsupervised pre-training on large corpus of data, large sentences of data or corpus of data. Okay. Then fine-tuning. Fine-tuning does not require here. Okay. But can be fine-tuned for specific task. And here, for a specific task, we have to do the fine-tuning. Requires fine-tuning for specific tasks. Okay. Here are some of use cases of GPT-3 and BERT. So these are the use cases, like it can be used for coding, machine learning code generation, chatbots and virtual assistants, creative storytelling, language translation. Okay. And in BERT, it can be used for sentiment analysis, text classification, question answering, and machine translation. Okay. So these are all the use cases of both the things. And based accuracy. Accuracy is based on superglue benchmarks, that is 86.9%. It is having an accuracy of 86.9%. Okay. And based on glue benchmark, it is having accuracy of 80.5%. Okay. So then GPT-3 and BERT based on 3 dimensions architecture size and learning approaches. As we can all say, by all this, by looking all these slides, we can say that GPT is built using a transformer decoder blocks. BERT, on the other hand, uses this is all the summary of this. Okay. Then BERT, on the other hand, uses a transformer encoder blocks. GPT-3 is trained on traditional on language model problems, which predicts next word, and BERT is trained on mask language models and next sentence prediction model. Okay. Then BERT uses a self-attention and GPT-3 uses a mask self-attention. Okay. Then there are parameters. BERT has 340 billion parameters, is trained on 340 billion parameters, and GPT-3 is built on 175 billion parameters. Then there is training data. Training data is BERT is trained on corpus of 2.5 billion tokens from the Wikipedia, and whereas GPT-3 is trained on corpus of 499 billion tokens. Okay. So now BERT has pre-trained models for different downstreams NLP tasks, which are further fine-tuned on custom data. GPT-3 has single model for all downstream tasks and does not require fine-tuning. GPT-3 does not require fine-tuning actually. Okay, but for if you want to do it for a specific task, we can do it. And GPT-3 learns from examples like zero shot, one shot, and few shot prompting techniques. So there are again one more thing. Okay, so this is it for today. Thank you. Goodbye.